to write equations and graph hyperbola. Okay, so for a hyperbola, once again, we've got a horizontal shift and a horizontal stretch right here, vertical shift and vertical stretch. But notice there's a minus here, whereas in an ellipse, that's a plus. And a minus is not commutative, so we actually do need a second version of this. Okay, so when we are horizontal, we're going to have x first. So that's going to be an ellipse that opens like that. A vertical ellipse will have y first. It's going to open like that. Okay, so we've got a horizontal or a vertical shift and stretch first, and then a horizontal shift and a horizontal stretch. Okay, the transverse axis, that's the one that's positive. The conjugate axis is the one that's negative. So here's a positive transverse axis and a negative conjugate axis. Okay, so the transverse axis follows the direction of the opening. So this opens left to right. So this transverse axis is the x-axis. All right, so this one has the x first, so it is going to open horizontally. Its center is going to be positive 4, negative 3. So at 4, 3, 4, negative 3, we've got a center. Okay, so next we've got a horizontal dilation of the square root of 4, which is 2. So we're going to go 2 in either direction. And a vertical dilation of the square root of 16, which is 4. 4 up and 4 down. Okay, now around that, we're going to make a little dotted rectangle. Okay, and then along those diagonals, we are going to draw a line. Okay, so we've built kind of a structure for our hyperbola. Since it's opening horizontally, this point and this point will be vertices for the two parts of our hyperbola, and that's the most accurate point that we're going to get. From there, we're going to go here and hug that asymptote. We'll go this way and hug that asymptote, and we'll do the same on this side. Here's another horizontal one because x is first. The center is at negative 5, positive 2. So we'll graph that, negative 5 and positive 2. The horizontal stretch is the square root of 4, so it's 2 left and right. The vertical stretch is the square root of 36, so it's up 6. And down 6. And from there we build a rectangle. And we use the diagonals of that rectangle for asymptotes. So on the center of the right side and the left are my vertices. And go out and hug those asymptotes with the graph. This one is vertical because y is first. So my transverse axis this time is the y-axis. It will be vertical. So the center, I still have to get the first component from this x. The center is 3, 1. Over 3, up 1. There's my center. Then the horizontal stretch is 5. The vertical stretch is 4. and I can build a rectangle. Then I do diagonals of that rectangle for asymptotes. And since it's vertical, now I'm using the center of the top and bottom as my vertices. And now we are going to write equations of hyperbola. So this first hyperbola opens up and down. It is vertical, so y will go first. The center of this hyperbola is at -3, +2. So I've got y minus 2 squared over something, and then I've got x plus 3 squared over something equals 1. The vertical stretch, 1, 2, 3, 3 squared, is 9. The horizontal stretch, 1, 2, 3, 4, squared, is 16. My second one is horizontal, so x will go first. The center of this hyperbola is -1, -3. So I'm going to have x plus 1 squared over something minus y plus 3 squared over something equals 1. The horizontal stretch, 1, 2, 3 squared is 9. The vertical stretch, 1, 2 squared is 4. And for my last equation, it's vertical again, so y. The center of this hyperbola is 3, -1. So plus 1 squared over something minus x minus 3 squared over something as soon as that 1 goes away, I can write again. Computer's been pretty slow since I've had an update, so as soon as we get going, change that to an equals 1. All right, after a lengthy pause, we are back. Equals 1. Okay, so now I have a vertical transformation or vertical dilation first. 1, 2, 3, 4, 5 squared is 25. And the horizontal dilation, 1, 2 squared is 4.